In this lesson, we are actually going to look at factorization. Now, in the revision lessons, you have actually looked at how to expand binomial products, also look at perfect squares. Now, the products of the perfect squares or the binomial products is actually in the form of ax squared plus bx plus c. And this is actually a quadratic equation. Now, in this form, ax squared plus bx plus c, a, b, and c are all given numbers. The x, of course, is the pronumerals. Now, we are going to first look at a unique case, which is a monic quadratic equation. In the monic quadratic equation, a is actually equals to 1. And therefore, we are actually going to look at factorizing x squared plus bx plus c. So remember, a monic quadratic equation is where a equals to 1. Now, let's have a look at this. When we actually expand a binomial product, it actually becomes a quadratic expression. From a quadratic expression, we can factorize it and it will become a binomial product. Always remember, expanding a binomial product, you get a quadratic equation, quadratic expression. And from quadratic expression, if we factorize it, we get the binomial product. So, in general, if we have got x plus b times x plus q, we know that from expansion, we've got x squared, which is that, plus px, p times x, plus qx, plus pq, right? Therefore, it's x squared plus, in the bracket, p plus qx plus pq. Now, this is actually in the form of a monic quadratic equation, b and c. In order to factorize this monic quadratic equation, we actually look for two numbers, p and q, where p plus q is equals to b, which is the coefficient of x, and pq is actually c, the constant. To make it a little bit more clearer, let's have a look at some examples. Right, let's first look at two examples. First one is x squared plus 6x plus 8. Second one is h squared plus h minus 30. Now, let's look at this and compare that to this equation. We know that p plus q has to be 6. P times q has to be 8. If we can find p and q, we can actually factorize it. X plus b and x plus q. Alright, let's try. We know p and q. Okay, 8. It could be 1 times 8. pq equals to 1 times 8, 8. But p plus q, that equals to 9, which is not 6. Therefore, p 1 and 8 is not the solution. What about 2 and 4? pq equals to 8. p plus q this time equals to 6, which is correct. Let's look at this again. P plus q, 6. pq is 8. So, we can actually write it in this form, which is x plus p and x plus q. So it is x plus 2 into x plus 4. Let's do a quick check. X plus 2 x plus 4. That, you should know the expanding that, which is the distributive law. That's x squared plus 4x plus 2x plus 8. That is equals to x squared plus 6x plus 8. Therefore, what we have done is correct. What about this one here? Again, I'm just showing you with PQ. Alright? Minus 30 could be minus 1 and 30. However, minus 1 plus 30 doesn't give you minus h. What about minus 2 and 15? Again, minus 2 times 15, that is 30. But minus 2 plus 15, that does not equal to plus 1. Alright. How about minus 3 and 10? We can find C, but minus 3 plus 10 does not equals to 1. This time, let's do minus 5 and 6. Alright, PQ equals to minus 30. P plus Q equals to 1. Therefore, this is the correct solution. It's x minus 5, x plus 6. That's how you factorize h squared plus h minus 30. In fact, this should be h and not x. Alright? Now, let's check this again. We've got h minus 5, h plus 6. Again, that gives us h squared plus 6h minus 5h minus 30. Therefore, that equals h squared plus h minus 30, which actually gives us the correct answer. Alright, a few more examples. First one, we've got a minus c squared plus 14c minus 48. Okay, let's have a look at this equation compared to that. In this case, we know that for a Monic quadratic equation, a has to be 1. But there's a minus here. That is quite alright. What we can do is rewrite this equation. If we put a minus 1 in front of this equation and then brackets it, we know that minus 1 times c squared will give us minus c squared. And minus 1, if we multiply it by minus 14c, that will give us plus 14c. And if we multiply minus 1 with minus 40 plus 48, that will actually give us minus 48. Therefore, rewriting this, it is just minus c squared minus 14c plus 48. Now, you don't actually have to write minus 1 out when you actually rewrite the equation. This is then in the form of x squared plus bx plus c. Let's factorize the bracket. Now, let's look for PQ. Well, we can try, say, 1 and 48. Although we know 1 times 48 gives us 48, 1 plus 48 is actually 49. So, it is not correct. How about let's try minus 4 and minus 12. So minus 4 times minus 12, that gives us plus 48. But minus 4 plus minus 12, that does not give us minus 14. How about minus 6 and minus 8? So PQ this time equals to minus 6 times minus 8, that gives us plus 48. And minus 6 plus minus 8, P plus Q, that gives us minus 14. Therefore, when we factorize this, it actually becomes minus C minus 6 and C minus 8. Alright, you can actually pause the video now, expand this, and see whether you can get the same answer. Let's continue on and look at this. How would you do this? Again, this is actually not in the form of Monic quadratic equation. But look at this: 2, 4, and 6. What is the common factor there? We can actually take 2 out. So therefore we have x squared plus 2x minus 3. Alright, I am actually just going to do the factorization by not writing up PQ. I'm just doing it mentally. So 2, we know what will give us minus 3 and plus 2. So PQ, if it is minus 3 times 1, that gives us minus 2x, so that's not correct. What about 1 times minus 1 times plus 3? That's actually give us 2x. So P, say, is minus 1 and Q equals to plus 3. So PQ gives us minus 3, P plus Q gives us plus 2. So that's x minus 1 and x plus 3. That's it. That's how you factorize this. I want you to pause the video for a while and spend some time and see, about say 3 minutes, see if you could actually rewrite this into the form of that and then factorize that. Alright, I think you've got enough time to do it now. Let's rewrite this into that form, which is 2s squared minus 10s plus 25. Okay, what two numbers will give us minus 10 and plus 25? P, Q. Could it be minus 1 minus 25? No, that's not correct. In fact, it's actually minus 5 and minus 5, because PQ in this case will give us plus 25, and P plus Q, that gives us minus 10. Therefore, it's 2s squared minus 5, actually not s squared, s minus 5, s minus 5. Now, remember, this actually is a perfect square. That equals to 2s minus 5 squared. Alright, as a summary, if we have a Monic quadratic equation, x plus bx plus c, in order to factorize it into the form as x plus q and x plus p, we need to look for two numbers, p and q, where p plus q is actually the same as b, which is the coefficient of x, and pq is c, the constant. Right, this is actually the lesson on factorizing Monic quadratic equation. Thank you for listening, and we'll look at factorizing non-Monic quadratic equation in the next lesson.